What's up, you data friends? It's Yanis here and welcome to my channel. Now, please note that this video is actually the second video of the Python tutorial for beginners in data science. And if we look at our path, actually let's do it in Excel. In the previous video, we have covered step 1 and step 2. Step 1 is downloading and installing Anaconda Python and Jupyter notebooks, and then step 2, it was the Numpy library. In this video, we are going to cover the Pandas library. So we are actually going to load some raw data from Excel and try to work with that data to clean it, transform it, change it, manipulate it in order to answer specific business questions, and at the same time, learn how to use the Pandas library. And then in the coming videos, we're going to do joins, MatPlotLib, so visualizations with Seaborn, and also machine learning models. Now, what's specific about this tutorial is that everything we are showing in all of the series is that the code is geared towards data analysts and data scientists and not developers or data engineers or software engineers or anything else. So everything we're going to be showing is things that you will potentially be doing as a data analyst or a data scientist using Python and using Pandas. Another thing is that I have this tutorial uploaded in my GitHub page, so you can download this notebook and write the code as I do in this video. So follow this video through. And before we jump into this tutorial, let me just say that if you're passionate about data science and data analytics, then please click the like button, subscribe to my channel, and enable notifications for my future videos. Right. Starting from where we left it last time, or if you're new to this tutorial, you can start from here. You don't have to go back and do NumPy arrays if you know how to use them. What is Pandas? So Pandas is a Python package library. Pandas is used for data manipulation and data analytics. And also two of the main structures in Pandas is the series and the data frames. Now, as a data scientist, I use data frames 99.9% of the times, but very quickly we want to cover the Pandas series before we do Pandas data frames. The first thing we need to do is to import or install our packages. So in case you do not have Pandas, then you're going to need to type in pip install pandas and then run this. So let me just run it quickly. Most probably it's going to throw me an error because I already have it. So I'm just going to remove this. You can also install it from the terminal. So if you click on start, type in Anaconda navigator, the prompt, and then right click and run it as an administrator. Click on yes. And then here you need to say pip install and then pandas, run this, and it's going to install pandas on your PC. After you install pandas, then we need to import it. So import pandas as pd and then click Control and enter in order to run. And now we have imported pandas in our notebook. Right, what is Pandas series? So series is a one-dimensional object which is similar to the vector we have explained in the previous video and also the one-dimensional array. So to create a series, you need to say S equals, so S is the object. You can put any letter or word you want to put here. pd.series and then open square brackets and pass your values. So as you can see in this series, I have used both an integer, a float, and then a character. And then when I call my series, you can see we have 28, 1.79, and then Yanis, and then this is an object. Right, so now if we want to create series by passing in a list and the index, so the index is basically, instead of saying 0 here, it's going to have the index of this 28, for example, the age. Actually, let's change this to like maybe 31 because I'm 31 right now. And then if I run this quickly, you can see, actually, this one is the one I need to change. We can see that we can have the same thing as before, pd.series, comma, and then the index. So instead of having 0, 1, and 2, I want to have the age, the height, and then the name of the person. Let's say you're creating a list that has details about people. And then if I want to index the series, I can just call the object. So S and then square brackets and then the index. So in our case, one of the indexes is the name. And then if I run this, we're going to have a return as Yanis. So this is how much time I'm going to spend on series because we don't really use them often. What we use is Pandas data frames. Right, so what is Pandas data frame? A data frame is like an Excel table or a pivot table because we can shape it the same way we shape pivot tables. So it's a tabular data structure that has both rows and columns. So it's like a table in Excel. It has rows and it also has columns. Right, first we're going to show how to create them ourselves, and then we're going to show how to load data from Excel into a data frame directly, which is what you're going to be doing as a data scientist or a data analyst. Right, how to create a data frame. All you need to do is type in pd.dataframe, and then you need to set the values and then the columns, but in our case, because we're going to create an empty one and then fill it in, we're going to start with the columns. So if I run this quickly, you can see it's completely empty. It's a table, but it's empty. It has name, gender, age, and height, which is the values we have passed in our data frame. Now, if we want to add values in our data frame, there is two ways of doing this. The first one is manually doing it like this. The second one is doing it from the beginning when you create the data frame. So just to show you how to do it manually, if I put a new row here, and then if I run this first one, and then if I also run our data frame. So now I have imported into our data frame the Joe as name, male as gender, and then 23 as age, and 1.70 as height. You can see we need to say .log or .ilog, and this helps us index data frames. We cannot really do, so let me run this quickly. If I do it the same way we index the arrays in Numpy, if I do df.0, you can see it's returning an error because this is a data frame, it's not an array. So we need to put .ilog or log, actually both work, .log or .ilog, if we want to change or select the first row of our data frame. Right, let's cut this now. If we repeat the same process for everyone else, you can see that we have added data into our data frame. Now, another way of doing it is to create a data frame from a list. So I can specify my list. So here I added Joe and Tom, so two of them, and then pd.dataframe, and then here, instead of having only columns equals, so versus the first way we created it, we can pass the list first at the beginning, same way as we have it here, and then comma the column names. So if I run this, you can see we created a data frame with two rows. Now we can also create a data frame from an array. So we can randomly generate this array, which we've shown before in the previous video. So this is a 5x3 array, and then we can pass this array as values. So here, instead of a list, I add the array, and then the columns, the three columns, so 5 rows, 3 columns, is revenue, cost, and visitors. You can see revenue, cost, and visitors. And the last example I have is how to create a Pandas data frame from Pandas series, which we've shown 5 minutes ago. So first we need to create our series, which is exactly the same as before. S equals pd.series, I pass my values, I pass the index, and then I can say pd.dataframe, and then name my column as details and take S index. So it's going to take age, height, and name, age, height, and name, and then as values, take the S dot values. So it's going to take 28, 179, and then Yanis. And then if I run it, you can see it's the same thing. Now, if I want to transpose it, we've shown this in the previous video. I can either say df.t capital or np.transpose, and this is going to turn the rows into columns as you see over here. Right, now the fun begins. So as I said in the first video, I assume that you're gonna find everything boring up until here and then after. And this is because now we're gonna load some real raw data and we're gonna start working with it using Python. So now it's gonna make more sense, but we had to do everything else before, so it gives you an idea of how Python works. Right, so the data set we're going to be using is actually from Kaggle, so you can either go into Kaggle and download this raw data. I have the link in the description there, or you can download the raw data from my GitHub page. I also have it here. And then what you need to do in order to load this raw data into Python is that you need to first give it a name. So I gave it a name of raw_data equals pd.readcsv, and then I need to specify the path and then the name of the file. So to get the path, you need to go into the folder where you downloaded the data. You need to right click, click on properties, and this is going to give you the path here in the location. You can copy this. Please note that this is without the name of the file. Paste it into this code. So everything until here before the name. Also, when you do paste it, you will need to use double backspace, I think is the name. So use double of these ones because singles don't work. And at the end, you're going to need to add the name of the file. So depending from where you download it, if you download it from my GitHub page, then it's going to be this name. But if you download it from Kaggle, it's probably going to be this name over here. Right, going back into our tutorial, if I delete this, so the first thing I do is that I load the raw data and then I load it into this raw data over here. So let me run it quickly. And then if I run this file I've just created, it's going to run all the raw data. So if I run it quickly, you can see it's from 0 all the way to 204. So it's actually 205 rows and 26 columns. And we can actually view our raw data. By the way, quick info on this raw data. If we go into Kaggle quickly, it says that it's car price prediction multiple linear regression data. So it's a Chinese automotive company that has some of the cars, so car names over here, some details for the cars, and also the price of these cars. But these are things we are going to investigate using Python, not Excel. Right, if we go back to Excel quickly, so over here we see that we've managed to load all of our raw data. The next thing I do is that if I want to run the first 5 rows, because I don't want to see the whole of raw data, I just want to see a snap of the raw data, I can actually say raw data.head. So if I copy this and paste it over here, if I don't put anything into the brackets, it's going to be the first 5 rows always. But if I do put a number, then it's going to be whatever that number is. So I say 2, then it returns the first 2. If I say 10, it's going to return the first 10 rows, as you see over here. The next thing I have is, I think we've covered everything here. We're just showing how to load the raw data and how to view our raw data. I'm going to delete this. The next thing we do is to show the tail, which is the opposite of here. So if I run this, it returns the 5 last rows we have in our dataset. Next, we have the shape. So if we put the name of our data frame .shape, if we run this, we can see we have 205 rows and then 26 columns. And if we actually check our raw data in Excel, we can see that if we select all the columns, we have 26 columns, and then the count over here is 206. So 26 with 206. This says 205 because it counts 0 as a row 2. So it's actually 206. Next, if we want to view some quick information about our data frame, we can run raw data.info and then run this. and this is telling us how many non-null values we have. So you can see we actually have all the data. We don't have any null values, which is great. Most of the times you're going to have null values, but I'm going to show you later on how to deal with the null values. And something else we get here is the D type, so the data type of each column. You can see car ID is integer, and if we check, you can see this is a car ID, is an integer, is a whole number. Symboling is an integer, these are objects. So the way I see it, some of them should have not been object because I assume that the drive wheel is actually a number. So if we check drive wheel, no, it's not, this is an object. Oh, they are all objects actually, sorry, my fault. So up until engine location, then we have float. So these columns have decimal numbers, then integer, then object. So object is when it's string, so it has characters, etc., etc. And all the data types in our file is float, 64, integer, and object. Next, if we want to check some of the summary statistics, so these .describe is going to return data for only the numeric column. So anything that is float or integer, it's going to skip all the objects. And you can see we have the count of car IDs, the mean, the standard deviation, the mean as in the average, the standard deviation, the minimum value, the maximum value, and some of the percentiles. So if we check, for example, the average car price, so where is it? The mean. If we check the mean for car price, we can see that it's on $13,276. Right, moving on, we have column filtering. So let's say you only want to select 1 or 2 or 3 columns from your data set. Then there is a few ways of doing this. If it's one column, then you can run this raw data dot and then the name of the column. And this is going to return just the car names. So we see this ... So this is telling us that there is more data in between. Another way of showing this is by saying squares and then pasting the car name into quotes. So it's exactly the same thing. You can see I prefer using this way over the first way just because sometimes there is spaces into the names. So if there is spaces, you cannot use the first way. So I personally only use the first way. And then if I want to see the first 5 car names, I can add the dot head, and this is going to return the first 5 rows only for car name. Additionally, if I want to see this back as a data frame, I can add double square brackets as we have over here, and this is going to return the data back as a data frame as you see it over here. Moving on, if I want to select 2 or more columns as a data frame, as you see over here, I can add into double square brackets the name of the car and also the price of that car. And if I run this, it returns only 2 columns. The next thing I have is if I want to select the unique values from a column. And the way to do this, the first example I have is by using the dot unique. This is with single square brackets and it's going to return an array. But if I want to have a data frame, then I can use double square brackets as we have over here and then say drop duplicates at the end. And if I run this, you can see that the result is not an array now, it's a data frame. So depending on how you want to have the result, you can use different ways to get the same result. The next example I have is that if we want to have unique values for more than just one column. So let's say I want to see the unique car bodies and the unique cylinders that each car body has. So for example, convertibles, as we see over here, only have 4 cylinder numbers. There is no other convertible over here. Actually, we do have the head, so there might be more data. Let's see. Sorry, I've made a mistake. As you can see, there's also convertible here and also convertible here. So convertibles have 6, 8, and 4 cylinder numbers. Sedans now have 4, have 5, have 6, have 12. So you can see now we see the distinct values of these 2 columns. Next, I'm going to add the dot head back so we can move on and show more examples. Next, we have how to create arrays from a data frame column. And the reason we want to turn these data frame columns into arrays is so that we can apply calculations on them, as I have down here. So the first example I have is that I can say np.array and then put the column in it. As you can see now, it's a whole array. Now that's an array, I can actually say .sum at the end, and this is going to sum all the prices, as you can see over here. Another way of doing this now is by selecting the column as is, so if I remove this, and then at the end saying .values. So this is again going to return an array where I can run calculations on it. Then another way of doing it is, instead of saying .sum at the end, from the data frame, which you see it works, I can just say .sum from the data frame. So this is the data frame, and it's automatically going to turn the column into an array and apply the calculation. And it's the same way with the NP array, and it's the same way with the dot values. So there is multiple ways of achieving the same result. Let me remove this. The next thing I have is, if we want to have a calculation for 3 different columns, for example, I can select these 3 columns, as we said, with double square brackets. I think we've shown the, where is it? Up here, where we select 2 or more columns. And at the end, I can just say .mean, so return the average of these 3 columns. So if I run this, you can see that the average car price is $13,000 something. The average horsepower is 104, and the average engine size is 126. And this is coming from our raw data, which is this Excel file over here. Right, moving on, we have the row filtering. So first, we're going to show how to filter the rows without conditions, and then we're going to show how to filter the rows with conditions. So the first example I have is, let's say you want to select the first 10 rows. So if we run this, square brackets, 0 to 9 is going to select the first 10 rows. It says 9 here, but it's actually 10 because 0 is included. Actually, no, it's 9. So I have to say 10. There we go, 10 rows. Now, let's say I want to exclude the first row. So I don't want to see it. I want to see data in between. What I can do is that I can say from 1 to 10, and this is going to exclude car ID 1. So if I run it, you can see it excluded number 1. Maybe I want to exclude the first 2. So I can do 2, and now it's excluding 1 and 2. Right, the next example I have is 0 to 2. So we've shown that. I'm going to remove this. Now I'm going to show you how to filter rows based on conditions. So this is like answering business question. The first business question is that maybe someone asks you, I want to see all the data where the car body is convertible. And in order to do this, let me copy this and I'll show you how to do it. First, I want to start with the condition. So my condition is raw data equals convertible. So if I copy this quickly and paste it here, so this is saying raw data and then the column and then equals. By the way, equals in Python or Pandas is double equals. Convertible, if I run this, you can see it returns only true and false. It doesn't return anything at the front. So in order to return the dataset now, you need to say, I want the whole dataset at the beginning, open square brackets, and then close square brackets. So I set the condition within the whole dataset. And if I run this now, it returns data that the car body, you can see it's only convertible. By the way, it's 6 rows, so we only have 6 convertible cars. And if I want to see those convertible cars alone, I can say at the top with square brackets, as you see, and into these brackets, I can say the car name. There we go. And then if I run this now, you can see I have the car names that are convertible. However, this result is as an object. If I want to see it as a data frame, I can add the double square brackets. as we said before. So now we see the car names that are convertible. And if I want to add more columns here, so let's say the price, I can add the price. And then if I run this, we can see all the convertible cars and their price. Right, if I check the second example is where the car body is not convertible. So it's exactly the same code, but instead of saying equals, now we have not equals, which is these two over here. Exclamation mark and equals means not equals. If I run this, you can see it's everything but convertible cars. So it's 199 different cars, different rows. Moving on, we have where the car body is not convertible. Alright, is when we select the individual car name. So I've actually shown you how to do this just a second ago. So this, instead of selecting the whole data frame, is returning only the cars, not the whole data frame. And the other example is when we return the car and the car body of non-convertible cars, which again, I've shown this a second ago. Right, moving on, the next example we have is selecting the car name and the car where genre is in convertible and hatchback. So instead of only having one condition, so car body is convertible, maybe we have two conditions. And equals only works for one condition. Sorry, one option, no condition. So what we can do, if I copy this and run it down here, this is selecting car name and car body, so these two columns, where the condition is that the car body, so the car body, which is this car body over here, let's add the let's do this, let's pin it home. Yep, the car body, this is the car body, is in convertible and hatchback. So dot is in convertible and hatchback. This is going to return all the cars that are either convertible or hatchbacks. And then the next example we have is selecting the car name and car body where genre is not in. So it's exactly the opposite. In order to achieve the opposite of this, so instead of is in, not in, you need to add this symbol in the condition. So if you add this symbol at the beginning of the condition, so these two square brackets, it's going to treat this as not in, not is in, but not in. So this is going to select all the cars that their car body is not in this list. And this list is convertible and hatchback cars. Right, moving on, the next example we have is that let's say that someone from the business asks you to select all the cars and the car body where the car name is BMW. However, we have many variations of BMW cars. So we need to search anything, any car name that their name is like BMW. And in order to do this, you need to put this condition in. So if I paste this quickly, you need to say row data car name .str. The reason we need this .str is because we are not searching in the absolute value of the column, so the whole column name, but we are searching within the strings. So anything within the strings that has BMW, whether it's starting or in the middle or in the end, is going to be back in the results. And then after the .str, we need to say .contains, and then in the contains, we need to say the string we are searching for. And the .tail at the end is that it returns the last 5, or if we put here the top 5, or if we completely remove it, it's going to return all the cars. There you go. Now, the other example we have is anything where the car name is not BMW. So we want to exclude all BMW cars. And we've shown this before. All we have to do is add this symbol. And now we're going to have all the cars but BMW. Right, let's cut this. The next example we have is where we want to select the car name and car body where the price is more than $10,000. So this is very simple. It's exactly as we've shown before, but instead of saying equals or like, now we have values. And because price is already mapped as float, I think, or maybe integer, we can run these numeric calculations or conditions on it. So all I'm saying here is return the car names, car body, and price where the price is more than 10,000. And if I run this, we can see we have loads of cars where the price is more than 10,000. Same way, we can do less than 10,000. So the second example, as we have over here. And if we want to have between 15,000 and 20,000, we need to add two conditions. And to add two conditions, we need to use the brackets. So the first bracket, my first condition, which is this one, I'm saying the car has to be more than 15, so $15,000. And the second condition now, we need to open brackets, and I'm going to copy this and paste it so I can change it quickly. We can say the price is less than 20,000. So let's put 20,000, and this should be more, not less, more. And if I run this, these are the cars that are between 15,000 pounds and 20,000, sorry, pounds, dollars, I'm not sure, I think it's dollars. But this is an actual business question. Someone might ask you, as a data analyst or a data scientist, show us all the cars that are in between this price range. And this is how you would achieve this. Right, moving on, we're going to show how to sort the data. So if I create a new row here, the first thing we want to do is to sort the data by price. So if I copy this and run it quickly, all you have to do is put the name of the data frame, then dot sort values, and then by equals, and then the column you want to sort the data by. In our case is price. So if I run this quickly and then we scroll into the price, you can see we start with the less expensive car and we go all the way to the most expensive car. Next, if I run raw data again, you can see that this is not actually saved, because if I scroll here, you can see it's random. And the way to save this sort back in the data frame is that we can either take this and put it here and say the raw data equals, and then this code, which is the sorted code, or we can say raw data.sort values by price, comma, in place equals true. So if I run this now, it's actually going to save the results or the sorting into the actual raw data. So if I run this, you can see now if I scroll at the end that it starts with the lowest and it goes all the way to the highest in the actual raw data. So the results are now saved back in the raw data. Next, if I want to sort the data by horsepower, but now I want to sort the data from highest to lowest and also keep in place equals true. So if I run this quickly, let's run it over here. We can find the horsepower, which is horsepower over here, and it starts from the highest now all the way to the lowest. That's because we put ascending equals false. Right, next we're going to show how to aggregate the data. So first we're going to start with simple column aggregations, which we have shown I think at the beginning, but very quickly, if we want to sum the price, we can either do it like this or we can do it like this. Both codes do the same thing. If we want to average now a column, we can say dot min, so very self-explanatory, or we can do dot max, dot min, and the last example we have is where we want to select the minimum value where the horsepower is more than, where the price is more than 20,000. So this is the data with the condition where we've shown actually in the previous step, and we can also apply calculations on top of our conditions. And this is because horsepower, so these numbers are integers. So at the end, I can say dot min, and this is going to give us the minimum horsepower where the price is less than 20,000. Right, the next aggregation we have is where we want to aggregate data by another category. So in our case, we want to select the highest, the highest price for each car body. So if I copy this up until here before the sorting, because with the sorting is a bit confusing. So what I'm doing here is that I am grouping the data by category. I'm setting the index as false because I don't want to re-index this. And then I say dot aggregate the data. So first I group it by car body, and then I aggregate the data by the max price. So what this is telling me now is that for convertibles, the max price we have is $37,000. For hatchbacks, for example, the max price we have is $31,000. We can also do price and mean here. We can do max, mean, we can do count. All of them are going to work. But this is how you would go if you want to aggregate the data by a different column. Now, if we want to add another calculation, so to aggregate the data with another column there, so let's say the number of cars per car body, we can add a comma here and then open quotes, add car name, and then the calculation for car name is not going to be min, max, or sum because those are not going to work on a string. Now we need to add count here, and this is going to count the number of cars that each car body has because we are grouping the data by car body. So if we run this quickly, you can see that we have 6 convertibles and the mean price is $21,890. We have 8 hard tops, we have 70 hatchbacks, etc., etc. Now, if we want to add another category over here, so we want to group by the data by car body, and also let's select another one. Let's do, let's say fuel type. So gas, or what's that, diesel, petrol or diesel. I can copy this, and then into the group by, I can add these square brackets, and then I can add comma, and then also add fuel type. So if I run this now, we have aggregated the data by car body and fuel type, and the aggregation is that we are showing the average price per car body and fuel type, and also the number of cars per car body and fuel type. The next step now would be to rename these columns, but I'm going to show that later on. Right, and the last thing I want to show is how we sort the data, because I have this sort data after we created this aggregation. So as we have shown before, we can add the dot sort values by, and then we're going to use price, and we want to have ascending equals as false. I don't want to have the head, so I'm going to copy this. I'm going to add it in our aggregation, and this is going to sort this new aggregated table by the highest price to the lowest price. But this is actually the mean, so this is actually the average price. Right, the next thing we have is that we want to count the number of car names per car body. So a quick way to do this, if I remove the head, is by adding the name of the column, so raw data car body, and then dot value count, sorry, it's by car name, it should be car body here, and then dot value counts, and then ascending equals false. So it's going to start with the car body that has the highest number of cars all the way to the lowest number of cars, which is the convertibles with 6 cars. Moving on, I have more examples of how we aggregate the data. So I'm just going to create a new row. Here we want to show the total price per car body. So if I copy this and run it, you can see we are grouping the data by car body. We are setting the as index as false. We are aggregating the data by summing the price. And then we are sorting the data by price, ascending equals false. So you can see that the car body with the highest price, not the highest price, the highest total. So if we sum the prices, is sedan with 137, is it? No, it's more, with 1,377,000 total price. The second example I have is that we want to have the average per car body. So we can quickly change the sum to the average, and now the highest average car body is hard top, which I have no idea what it is. The next example we have is that we want to show the average price per engine type. So it's similar code, we're just changing the columns now, and the engine type with the highest average price is DOHCV. And the last thing we have is that we want to show the total price and the average horsepower per car body, and we want to sort the data by price. So if I run it, you can see that the average price for sedans is it the average? No, the total price for sedans is 1.3 million, and then the average horsepower is 103. This doesn't make sense though. We need to put a mean here, so we show the averages. So the average is 22,000 with 142 horsepower. So you can see that sedan goes away when we use the average, and then the highest average is actually the hard tops with the highest horsepower too. Right, down here we have more examples. So these examples is when we use two columns, which we've shown them again. So now we want to show the total price per car body and drive wheel. So car body and drive wheel in the group by, and then in the aggregations we sum the price and then we sort the values. So you can see is sedan and then rear wheels and then sedan and then front wheels. So sedan have the highest totals, so when we sum the data. But if we do mean, I'm sure we're going to have those hard tops. There we go at the top. And the next example we have is we want to show the total price. So sum the price and then mean engine size for car body and drive wheel. So again, we are changing the names and we are playing with the aggregations. And the last example we have is where we have three aggregations. So let me run it quickly. So if we run this, we want to show the car body and the drive wheel, and then we want to sum the price. So we are summing the price. We want to average the engine size, and we want to count the number of cars. So we can see that we have 36 sedans rear wheel with a total price of 78,000 and an average engine size of 165. Right, so we have shown many examples of how we can use the .agg to aggregate data and create summary tables in Python using Pandas. This is something that you're going to be doing very often in your job as a data analyst or a data scientist. So make sure you learn very well how to run these examples, these aggregations, and how to create summary tables. Right, moving on, we are going to show how to create new fields. So very quickly, let me create a new row and paste the head of this so we can see our row data. We have 26 columns and 5 rows. This is the head, but we have 200 something rows. What we want to do is that we want to create a new column at the end now that shows the relationship between price and horsepower. The way to do this now is that we need to put the name of our data frame, row data, and then the name of the new column, which is going to be the price per horsepower. And then we want to take the raw data price, which is this price, this number, dividing it with the raw data horsepower, which is this number over here. So if I run this now, we can see that we're going to have a new column at the end, which we didn't have before, that has the relationship between price per horsepower. Right, the next example we have is that we want to create a new field based on a condition. So if the price is higher or lower than the average price of all time of the whole data set, then add price above average or price below average. So the first thing we want to do here is to calculate this average of the whole data set. And in order to calculate it, we want to select the price and then say .mean at the end. So if I run this quickly, and then if I also display it by running it, we can see that the average price for the whole data set of all cars is about $13,000. Now, in order to create this new field, I have to first specify the new field, as we said before. So this new column, new field, is going to be the car price versus the average price. Then I need to say equals np.where, and np.where works like an if statement. So if the price is more than the average price, which we have calculated above here, comma, then value if true, and then value if false. So, comma, price above average if this is true, or value if false is price below average. And then if we run this quickly, and then we show the head, so we show how this is going to change, we can see that we created this new column now next to price per horsepower, which we have just created, that has price above, 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 above. We don't have any below. Actually, in order to see a summary, we can do dot value count of this new column, and we can see we have 129 cars below average and 76 cars above average. Right, so this is how you would go about creating a new column. We've shown two examples. Right, and the last thing we have is for loops. Now, for loops are a bit more advanced, but we're going to show this example and try to explain it as best as possible. Right, we want to show if the price is above or below the average price of its respective car body. So what we need to do is that we need to calculate this car body average, which we have shown how to do this previously in the aggregations. And then we want to compare this Porsche Cayenne, which is a hatchback, if its price, which is 31,000, is higher or lower of the respective car body. So we said that this is actually a hatchback. So if this price, which is 31,400, is higher or lower than the average of the whole category, so if it's higher or lower than this 10,000, which is higher, and then create a new column, and in this new column to have if it's higher or lower than this price. Right, in order to do this, the first thing we want to do, let me create a new cell over here. The first thing we want to do is to create a list that we want to loop through. So this list is going to be, let me paste this. This list is going to be all the car bodies. So we have 1, 2, 3, 4, 5. So we are actually going to loop 5 times. Then we want to create this new field, and this new field is whether it's above or below the car body average. So I'm actually creating this new field and I'm setting everything to be below. So if I select my raw data now, I have everything as below in this new field, and this is because I want to first create this field and then loop and update this field if it's above average. By the way, there are multiple ways of achieving this, but I'm going to follow this way that I show you. So we're going to start by saying for C in car body list, then print C. So this is going to basically do a loop and do nothing, no actions. The only action is by looping through this list we have just created. The next action now is to limit the data into the respective car body. So what this does, it's creating a new data frame, and this data frame is equals the whole data frame. However, we are selecting the car body equals C. And C is going to start with hatchback, and the last one is going to be wagon. So if I run this now and I select the last data frame we created, everything should be wagon. So if I select this, you can see that everything here is wagon. And it starts with hatchback as we said, then it does sedan, but because there are no actions, I'm not calculating or editing or updating, it's just looping through. The next thing I'm going to add now is to, calculate the mean of the category. So if I run this now, what this is going to do is going to select the data price. So it's going to select this price. Where is it? this price for the respective car body and just calculate the average. So if I run this, actually let's run it without the loop. So we see the number, and then with the loop. So you see the number is 12,371. And if I run this quickly, and if we paste this and run it, we can see it's the same, because the last car body, it was wagon as we said, and we save wagon's average into this car body mean. However, each time we loop, this mean is going to be different. We can actually print it, so you see that each time is going to be different. There we go. You can see the first category, the mean, the second category, the mean, the third category, the mean, and it goes on and on and on. Right. And the last thing we want to do now is that we want to update this field we have just created. And in order to update this field, we have to first select the field, as we have done here. Then we want to add a condition in this field. So the condition is, if the car price of each row is higher or lower, actually it's higher, sorry, than the average positive, oh, this is wrong, not positive rating, is higher than the car body mean, sorry, it was from a previous code, then add more, otherwise it's going to stay as below. So it's either below, actually let's do above, so it makes more sense. So if I run this now, and then we run the data, just to, not the data, let's run the row data. So let's run this. We can see that we have above, and this is because we've sorted the data by the highest horsepower, I think. So the stronger cars are going to be at the top, and the less strong cars are going to be at the end. There we go. So these ones are below. And if we do a value count, so let's do this value count we've done before. Where is it? Here. Sorry, I'm going to copy the whole thing, paste it over here, and then change the fields. So we see how many cars we have above and how many we have below. There you go. So you have 104 cars that are below their respective category and 101 cars that are above their respective category. So this is one example of a for loop. Down here, I think I have another example, and let's see what this does. Show if the price is above or below the average price of its respective fuel system. So we repeat the same process, but instead of having the car bodies as the list to loop through, we loop through all the fuel systems. So we create a list with the fuel systems, we create a new field and we set it as below, this should be above. Then we start the for loop, we print the F, so this is going to go through all the fuel systems. These are the fuel systems. Then we limit the data into one fuel system at a time. Then we calculate the mean price for this fuel system. And then we update the new field we have just created here, whether it's above or below the mean fuel system price. Right, so this is the end of this Pandas tutorial, which is actually the second video of our whole series. I hope you've enjoyed this video and you've gained enough value out of this video. And if you feel like you did, please click that like button, subscribe to my channel, and enable notifications for my future videos. In the next videos, as we have it here, we are going to cover the joins and how the joins work, and then we're going to do visualizations using MatPlotLib, and then we're going to use Seaborn down here at the end, and the last thing will be machine learning models. Right, if you have any comments or any thoughts or any questions, please let me know in the comments below. Otherwise, thank you very much for watching this video, and I'm going to see you in the next video.